Today I am going to explain choice of indicator in different acid-base titrations. How we choose indicator for acid-base titration. In acid-base titration part 1 video, we understood the theories and fundamental concept of acid-base titration and mechanism of indicator action. In this video, that is acid-base titration part 2, we will understand how we choose indicator for acid-base titration, that is choice of indicator. So choice of indicator, we add indicator in different titration because we judge endpoint. The color change by indicator must easily detectable and there is minimum titration error. That means endpoint or detection of color change near to equivalence point of the titration. So choice of indicator depends upon nature of acid base involved in titration because change in pH during the titration gives the correct choice of indicator used for that titration. So types of acid base titration is titration of a strong acid with a strong base, titration of weak acid with a strong base, titration of weak base with a strong acid, and titration of weak acid with weak base. So first is titration of a strong acid with a strong base. For understanding titration of strong acid with a strong base, suppose that reaction of 0.1 normal HCl 50 ml reacts with 0.1 normal NaOH 50 ml. As reaction proceed further, more hydrogen ion from HCl reacts with hydroxide ion from NaOH to form water, and the concentration of hydrogen ion goes decreases, results in rise in pH. When exactly 50 ml of NaOH has been added from burette, then equivalence point is reached. At this point, neither HCl nor NaOH is present in reaction mixture, so the mixture will be neutral and pH will be 7. NaCl will be formed from the reaction which is highly stable and will not undergo hydrolysis, so pH remains 7 at this stage. So from above reaction, the equivalence point reached at pH 7, so indicator will change its color at this pH, that is pH 7, but we cannot conclude that which indicator is suitable for this reaction. So in order to know suitable indicator, we must find out that how pH changes during the titration. So change in pH during titration of a strong acid and a strong base. The titration between 50 ml 0.1 normal HCl with 50 ml 0.1 normal NaOH from burette. So pH before any NaOH is added, the concentration of HCl is 0.1 normal. So we can say the hydrogen ion concentration is 0.1 normal gram ion per liter, that is equal to 1 by 10 gram ion per liter and 10 to the power minus 1 gram ion per liter. As we know, pH is equal to minus log H plus, so by multiplication by minus log in both sides, we determine pH of the solution. So multiply log in both sides. Log H plus concentration is equal to log 10 to the power minus 1, which is equal to minus 1. Then multiply minus in both side, minus log H plus concentration is equal to minus bracket minus 1 is equal to 1. So pH of the HCl before added NaOH is 1. In point 2, pH after adding 10 ml of NaOH from burette, 10 ml of NaOH reacts with 10 ml of HCl, then 40 ml HCl left and total volume becomes 60 ml. In this condition, pH of HCl is calculated from normality of HCl as in point 1, and normality of HCl can be calculated by N1V1 equals N2V2, that is N into 60 equals 40 into 0.1, means normality of 40 ml HCl in total volume is equal to 0.667. Then by direct calculation, pH equals minus log H plus is equal to minus log 0 0.0667, which is equal to pH 1.18. So as said in last slide, pH of the HCl at this point is 1.18. There is rise in pH from 1 to 1.8 when 20% reaction completed. So pH after addition of 20 ml NaOH, normality of HCl is calculated same as 0.1, that is N1B1 equals N2V2, and H plus concentration is equal to 0.0428 gram ion per liter, and pH will be 1.37 after completion of 40% reaction complete. In point 4, pH after addition of 50 ml NaOH, at this stage equivalence point reached because 50 ml NaOH reacts with 50 ml of HCl to form NaCl and water, and NaCl salt is formed from a strong acid and a strong base and do not hydrolyze in water, and pH of the mixture is neutral, that is 7. In point 5th, pH after addition of 50.1 ml of NaOH, at this point 50.1 ml NaOH reacts with 50 ml of HCl, and 0.1 ml of NaOH remains in excess, and total volume of solution will be 100.1 ml. For calculation we take 100.1 ml or approx 100 ml. In 100 ml of solution, 0.1 ml NaOH in excess, so at this point solution of mixture contained NaOH, and only normality of NaOH can be calculated. As you know, we calculate pH from normality. By calculation of normality of NaOH, we found out pH from it. So normality of NaOH in 100 ml is equal to 0.1 normal NaOH 0.1 ml. Then normality of NaOH will be 10 to the power minus 1 normal. Now normality of NaOH is equal to 10 to the power minus 4 gram ion per liter, which is equal to hydroxide ion per liter, and that is hydroxide ion concentration is equal to 10 to the power minus 4 gram ion per liter. As said in last slide, hydroxide ion concentration is equal to 10 to the power minus 4 gram ion per liter. As we know, concentration of H plus and OH minus, total concentration of H plus ON minus is equal to 10 to the power minus 14, and now we put the concentration of hydroxide ion into it, that is 10 to the power minus 4 into it, then H plus concentration into 10 to the power minus 4 equals to 10 to the power minus 14. And now we calculate the H plus concentration from the formula, that is H plus concentration is equal to 10 to the power minus 14 divided by hydroxide ion concentration, which is equal to 10 to the power minus 14 divided by 10 to the power minus 4, which is equal to 10 to the power minus 10 gram ion per liter. And by applying pH calculation same as earlier, pH will be 10. So pH of the solution is determined after completion of reaction and by concentration of NaOH. So in my next slide, table shows pH change during the different volume of NaOH added. In this table, the titration of 0.1 normal HCl 50 ml with 0.1 normal NaOH. pH change when no NaOH is added is pH 1, and after adding 10 ml of NaOH, pH is 1.18. After adding 20 ml of NaOH, pH is 1.37, and after adding 30 ml of NaOH, pH is 1.60. Then after adding 50 ml of NaOH, pH is 7. At this point all HCl reacted and there is no HCl. Then after adding 50.1 ml HCl, there is 0.1 ml HCl in excess. At this stage pH is 10. The result in table shows that when we add 0 ml to 49.9 ml NaOH, pH increases gradually from 1 pH to 4 pH, that is by 3 units. When we add 50 ml NaOH, pH jumps from 4 to 7 pH by 3 units, and when we add 0 to 49.9 ml NaOH, pH rises by 3 units, that is 1 to 4, and when we add 50 ml of NaOH, pH rises again by 3 units just by adding only 0.1 ml of NaOH, which is just near to equivalence point. One more point is obvious from result of table is when we add 49.9 ml of NaOH, 99.8% reaction is complete and pH rises 1 to 4 pH, and after addition of 50.1 ml of NaOH, indicator shows color change and there is excess of NaOH, that is 0.1 ml NaOH, which is equal to 0.2%. So the difference between end point and equivalence point is 0.2%, also called titration error. At this stage pH is 10, again jumps by 3 units. So the indicator shows its color change after pH 7. There is sharp rise in change in pH from 4 to 7 to 10. So the indicator between pH range 4 to 10 can be used for this titration, and titration error will not be greater than 0.2%. So in between pH 4 to 10 we use indicators such as methyl orange, bromocresol green, methyl red, bromophenol red, bromothymol blue, phenol red, and phenolphthalein indicator. The results of titration is graphically represented in this graph. We see in this graph there is sharp increase in pH when we add 49.9 to 50.1 ml of NaOH, that is 4 to 7 to 10 pH. So in between these pH we add above said indicators. So in next titration, the titration of weak acid and strong base, which will you see in acid base neutralization titration part 3 video. So thank you very much.